We're going to look at Chapter 4, Section 5 today, Scatter Plots and Trend Lines. You can see we've got our goal to create and interpret scatter plots and use trend lines to make predictions. There are quite a few vocab terms, so if I can clear some of these away, give you some time to take a look at these and write them down. Scatter plot is a graph with points that show a possible relationship. Correlation is the relationship between two sets of data. They can be positive, negative, or no. It's possible to have no correlation. A positive correlation is when both data values increase. If I scroll down, we can grab some more vocab terms here, and I'm just going to get rid of some of these boxes. A negative correlation, one data value goes up while the other one goes down, so they kind of have an opposite effect. No correlation is when there's absolutely no noticeable relationship between the two data sets, or you could say no relationship or no correlation between the two variables. And a trend line. A trend line is a line that we lay over a scatter plot to point out the trend, if it's generally going up. For example, I would like to say that the more hours students spend studying, the higher their grades get. So as those hours go up, their grades should go up. And a trend line would show that. A negative correlation could be the relationship between students' grades and the number of hours they play Fortnite. For example, if they're playing Fortnite for 30 hours a week, we would expect that their grade maybe is lower than if they're not playing Fortnite at all or only playing 5 hours a week. No correlation, just two data sets that are completely not related to each other, maybe the color of your eyes and your grade in algebra. Really shouldn't be a relationship there. So you can pause this for whatever time you need to finish writing down your definitions. And then we will go on to the next page. So example 1, it wants us to graph a scatter plot from the given data. Kind of a weird example here, but there's a number of cookies left in a jar over how many days. So we've got a table that's already set up for us. We'll call the days our X input variable, and we'll call the cookies, how many cookies are left, our Y, our dependent variables, meaning the number of cookies left depends on how much time or how many days they've been in that jar. And if I scroll up here, I think we can get this in the screen. So X will be my days. I'm going to skip some here. I'm going to go 1. This will be 2, 3, and 4, just to stretch that out a little bit. And then my Y values, we can go by, we better go by 4s. Actually, 3s will work. We can go 3, 6, 9, 12, there's 15, 18, 21, 24, and now we can start to plot our points. When there was 1 day in the jar, we had 24 cookies left. So that point would be right here. After 2 days, there was 16 cookies left. So 2 days, 16. After 3 days, there were 10 cookies left. So 3 days, 10. And after 4 days, there were 7 cookies left. Now, we're going to see examples on the assignment, and you've already seen some in the other videos of different scatter plots, but this one, certainly the more time that those cookies have been made sitting in a jar, the fewer cookies that are left. So we see there's a trend where these data points are going down. Okay. If I go to the last slide, this is the correlation piece. A positive correlation is when both things are going up, both sets of data are increasing. So the example I used earlier, this might be hours studying and this may be your grade. And we would expect to see that as you study more, your grade could increase. A negative correlation is the opposite. The example that I used was Fortnite, or it could be any game. So the hours you spend gaming, that could affect your grade in a negative way, where the more time you spend, if this is time, the more time you spend doing something outside of homework and studying, your grade could decrease. No correlation. This could be any two things that are not related. It's a true scatter plot. These data points are scattered throughout the graph, and there's no real trend. So just kind of one question to finish with. What kind of correlation would you expect to see if we were to make a scatter plot comparing your height to your age? So if we broke down your ages, maybe we go with months, or even just years and months. Typically, within a grade level, we're pretty similar. But now if we said, well, let's look at all kids, kindergarten through 8th grade. What do you think would happen to their height as they get older, from kindergarten to 4th grade, 4th grade to 7th grade, 7th grade to 8th grade? Typically, over time, students get taller. And we would say that is one of these type of positive correlation graphs.